So, how do you think about the different sound quality come from the PCM signal and the DSD?
Oh yeah, DSD is my
argument between.
Yeah, I can see why some people like DSD. It's a little complicated because if you were to take an average DAC, normal DAC, using normal chips, and have a DSD DAC or a PCM DAC, the DSD DAC would be more musical, and it would be more involving, and probably the soundstage would be better. Simply because a normal DAC has very poor filters, so the timing recovery is a problem. So it's a weakness. Yeah. But with my DACs, that's not the case, because I can, the timing accuracy is very, very good. So you don't have the timing problems. It means we have to have a very sophisticated DAC, with lots of processors and what have you, but the timing accuracy innately is better. So when you listen to DSD with my DACs, you hear big problems that you don't hear on other DACs. Against PCM, the soundstage is very flat with DSD. And you remember I was talking about the noise shape of performance, and that going from 330 dB to 350 dB, that changed the perception of depth. Now with DSD, we're stuck at 120 dB, so it's got huge problems of being able to reproduce small signals accurately, and they're very measurable. You can easily measure those kind of problems. And when I use PCM, that has problems from the recordings, but they're nowhere near as bad as DSD, because a PCM DAC will use a 5-bit running at 6 megahertz, not a 1-bit running at 6 megahertz. So it's innately got more resolution for small signals. So that's the one problem. The DSD sounds flat when you hear it on Dave, or you hear it on Mojo, it will sound flat. The other problem is that it sounds very soft. Now, some people like that sound. A nice soft sounding, everything warm sounding, everything rose tinted. And if you like that sound, fine, I'm not going to argue with you. Because people like that sound, that's fine. The reason it sounds, and if you take a DXD file and then take a DSD file that's been recorded from the DXD file, you hear two things. First, you hear the soundstage getting flat. Second, you hear it sounding very soft and warm, and lacking in the ability to hear the starting and stopping of notes. That sounded to me exactly like timing problems, because remember I was talking about Hugo, and I went from 16fs and improved the filter and improved the timing characteristics. Things sounded sharper, and you could hear the starting and stopping of notes, so that when you got that transient, that original crack, on DSD it will sound blurred and it sounds soft. You don't get that natural crack. On PCM you hear that crack, at least with a WTA filter. I knew it was a timing problem, so I did some simulations of DSD. And I found actually that DSD does have quite a severe, it's not as severe as PCM with a crap DAC, but it does have a timing problem. When you do a small signal, let's say you have a signal that's DC slightly negative and goes DC slightly positive. So it's a kind of square wave, but it lasts for a long period of time. When you do a big signal, full scale, fully negative to fully positive, and you do that signal on the left channel, when you do a small signal on the right channel and then look at the output from the DSD, you see that with the big signal there's very little delay. With the small signal there's a huge delay, several microseconds worth of delay. So as signals get smaller, the timing of the transients have a longer delay. And the brain detects that, and it blurs the transients and the brain, when the brain can't make sense of something, it just shuts it down. So you can't perceive the starting and stopping of notes properly because of these timing errors. So the only way of solving that problem is not to use DSD. And that's why I've been working on the Divina project, which is a pro audio HD converter. This will have a number of interesting things. For one thing, it's going to have a noise shaper that runs at more than 350 dB performance. So the analog noise shaper for the A to D is going to be 350 dB as opposed to the normal 140 dB. So I'm hoping we're going to get much better depth through production. The other thing that A to D's, pro audio A to D's converters have got is that they've got very crude decimation filters. And they'll create errors at a few hundred kilohertz. And generally the argument is, well, if this aliasing image is at a few hundred kilohertz, it doesn't matter, because you can't hear at 100 kilohertz. But it does matter. And the reason it matters is that it changes the timing of signals, of transient signals, in the audio bandwidth. And when you have these aliasing problems, you're screwing up timing, and that's screwing up perception. Now that problem I can fix because I've got a massive FPGA that's going into Divina, and I can make sure that when it decimates there is no timing problems at all, that we get a pure signal. That's another issue. A third issue, which is prevalent with A to Ds, is noise floor modulation. And we'll see here, when you use the A to D that's on the APX, the innate A to D itself is only minus 170 dB. But when you do the measurement here, it's at minus 180 dB. The reason this works is that they've got a special mode within the APX. It's got two A to D converters. What they do is they notch out the analog signal, the 2.5 volts, and feed that notch signal into one A to D converter. And then they feed this signal into another A to D converter, and then this part gets stitched up together in the digital domain. So when it's reproducing the distortion and noise, it's going through an A to D converter that's only got a small signal in there. So it doesn't have any noise floor modulation because it's only seeing a small signal. But you can see that even the best A to D converter you can get on the planet today, it's still got 10 dB's worth of noise floor modulation. Now, my A to D converter technology has no measurable noise floor modulation. So that's another benefit that we're going to get with. So, yeah, you can't solve DSD's innate problems. You've got to fix it by using PCM. The downside to it is that your DAT needs to be better, but that's not a problem for me.
I got Mojo.
All right.
Yeah, and this is my reference point for that.
Yes.
And the things that I best in Mojo is when I listen to the MP3 sources.
Yes.
So
Why does MP3 sound so good?
Yeah, why? I don't know.
I had this on Hugo
Mm.
because I used to listen a lot to AAC
yeah.
at 320k. It was originally 128k, and it went. BBC Radio 3 went up to 320k. And the thing I noticed about Hugo was that I was listening to the Radio 3, through the internet, much more often than I had before. Before I used to listen 2 or 3 hours a day, and I'd work, and most of the time I'd work in silence. With Hugo, I was listening all the time. And what was really weird was that when I had a hard problem to solve, normally you need silence, because you need to concentrate. And with Hugo, I could just leave it playing. And I thought, oh, this is odd, because I'm hearing the benefits of Hugo with AAC compressed music. And it didn't make any kind of sense to me that you could hear these benefits. Actually, I got intrigued by this and looked at measurements they'd done with AAC, not MP3,
Yes.
AAC, 320, and they did some digital measurements, and it reproduced, they had a 32 tone test, and it reproduced that almost perfectly, almost as if it was the original 16-bit 44.1 file. So there's no noise or modulation, and it reproduced the high frequency 20 kilohertz tones, full bandwidth perfectly. And I knew actually that performance was better than most DACs. So the issue is, DACs are really, really poor at reproducing transient information. And AAC is actually quite a lot better than people think. So yes, I agree with you. With Mojo, you can listen to AAC and it sounds quite listenable.
Yeah.
CD is better, but it sounds very listenable and it's musical and enjoyable. It's weird because you play AAC on a normal DAC and it just sounds bloody dreadful. And that's also what's weird about what happened with Hugo and Humming Mojo, was that in the past, whenever I improved a DAC's transparency, you heard what was wrong with the recording, and it wasn't necessarily musically better. But what was weird with Hugo was that rule didn't apply. And I couldn't get my head around this. It was so much more transparent, but you could hear what was good about the recording and enjoy the music. You would hear what was wrong. I play 1930s mono piano music. It's very hissy, it's very noisy. Some of them are from vinyl, not vinyl, even, you know, the drums. And the recordings are very distorted, very noisy. But you can enjoy the piano because it sounds like a real piano with a lot of distortion and noise thrown in. That's what it sounds like. On normal digital, it doesn't sound that way. It sounds like very distorted and very unpleasant. You don't hear the real instrument. And that's the beauty of Hugo and Mojo. You can hear the real instrument and enjoy the music, even if it sounds a bit distorted, even if the EQ is wrong. That doesn't matter. I've kind of summarised that the problems with digital are very, very profound and very unnatural. The ear and the brain can't cope with these distortions. They can't cope with the timing. They can't cope with the noise cell modulation. They can't cope with the peculiar problems that digital has got. The brain is normally used to dealing with distortion because the ear generates a lot of distortion. Air creates distortion. And the brain is used to dealing with that, but it's used to distortion that increases with signal. It's not used to distortion that gets larger as the signal gets smaller. It's not used to transient timing being wrong and being out of focus. It can't deal with that. And these fundamental flaws are something that really upsets the brain's ability. And that's why when you solve those problems, distorted music becomes acceptable. We've been selling Hugos into recording studios in the UK. And I was speaking to a recording engineer, and he uses it for mastering. And he said, what's lovely about Hugo was that I can hear exactly what is wrong with the recording. But I can hear exactly what's good about the music as well. And so as an engineer, recording engineer, he can make changes to the recording because he hears it. But he can enjoy the music because it presents the music correctly. And that's the beauty of it. And it caused me great problems because I couldn't understand why something that was fundamentally more transparent but was actually a lot more musical. And to me it was just amazing because I could really enjoy my music. And I've never been, before Hugo, I didn't enjoy music anything like as much as I do now. And you can even enjoy poor quality music. It's really weird.
The last question is that a lot of DAC manufacturer they build it up with a big and heavy power supply. So
Yes.
So why? Or
Don't do that. Power supplies are very, very complicated, and the influence it has on the sound quality is very profound. Like I was talking about the reference power supply for the flip-flops. Now, each flip-flop, and there's 40 flip-flops, each flip-flop will see an impedance of less than half a milliohm. And the noise levels are 300 nanovolts from the reference supply. So we're looking at 300 nanovolts of noise, 0.5 milliohms of impedance. That performance quality you will never get from a big transformer and a big power supply. It's down to very sophisticated analog designing. And it's very small circuitry that gives you that level of noise and level of performance. But that's where you need to spend your money and your expertise and your effort, not on having a big transformer and a big reservoir caps. That's the dumb way of solving power supply problems, because it will only go a little bit better. Actually designing each individual reference supply discreetly and correctly, and getting the RF noise levels is a major challenge within a DAC, and is one of the reasons we get no measurable noise is from the treatment of RF noise. So how RF noise is filtered, that's very, very difficult to do. So the thing about Dave, you open it up and you see a tiny switch mode power supply, and you see lots of surface mount components, and people will say, well, it hasn't got a decent power supply. It's actually got the most sophisticated power supply in the world. It is not a big thing. And my problem is getting through to audiophiles that actually this is actually a very sophisticated power supply and a very high performance power supply, and getting them to understand that.
Yes.
That's the problem, because people look with their eyes,
big,
that must be better. And it's way more complicated than that, much more complicated than that. Which is why audio is so interesting.